Welcome back. Today, we are completely flipping the script on how we look at the universe. We're putting away the telescopes, and instead, we're going to look at reality from a totally different angle. What if we think of the universe as this immaculately designed software architecture? I mean, picture it. Everything around you, the chair you're sitting in, the stars overhead, all of it, just the output of highly structured, deeply complex code.
So, what if space and time are just the output of a cosmic rendering engine? I know, it sounds straight out of a sci-fi movie, right? But mathematically speaking, this is an incredibly compelling framework. I want you to really rethink your physical reality for a second. What if everything you feel, everything you experience, is literally just the tactile output of a background computational process?
Okay, let's dive into this. We're unpacking some seriously dense math today, specifically Logos field theory and J-theory. Now, don't let the heavy terminology throw you off. We're going to break this all down together. At their core, what these theories are actually describing is the ultimate universal operating system. They mathematically detail how the universe acts as a flawless cosmic compiler, basically taking raw background data and translating it into the physical existence we see every single day.
Section 1. Reality as a cosmic compiler.
Before we can even begin to understand the physical world, we have to look at the foundational code of existence itself. Imagine a central vertical axis. This is the Riemann Zeta critical line. Think of it as the continuous space that we actually move around in, our rendered reality. But branching off from that main line are these discrete segments, known as p-adic code blocks. These blocks are the raw, unrendered math. They're literally the underlying data structures holding reality together right behind the scenes, just waiting to be processed.
The whole system architecture follows 4 distinct steps to bring those code blocks to life. First up, you have the timeless global Adele ring. Think of this as a static, 100% complete database of the past, present, and future, just sitting there. But without an observer, what the theory calls the J-unit, to actually partition that data, reality remains this completely unrendered, timeless archive. It's only when the J-unit takes action, executing a vertical sweep called a melon transform, that the raw code gets mathematically decompressed into the 4th step, the active, rendered 4D spacetime you are experiencing right now.
Section 2. The observer and the clock.
So if reality starts as this unrendered static database, how does it actually get processed into the continuous flowing time that we live in? Well, it happens at exactly 23.6742 megahertz. And I'm not using a metaphor here. In this framework, reality requires a literal master hardware clock to process time. This cosmic clock refreshes our physical universe at a blistering rate of 42.24 nanoseconds per frame. If you've ever bragged about your gaming PC's frame rate, yeah, the universe definitely has you beat. Every single second of your life, every movement you make, is being generated frame by frame at that exact frequency.
Now, what's really interesting about this is the trajectory of that observer node, the J-unit. Think of the J-unit like a localized read head scanning across a hard drive. As it sweeps vertically upward along the positive vector, it intercepts data points that render standard matter and forward-moving time. But if that read head sweeps downward in the negative direction, the math entirely flips. That exact same process generates antimatter and backward time. So time isn't some invisible river flowing past us. It's quite literally just the direction the read head is moving.
Section 3. Mass, lag, and gravity.
To really bridge this concept of a master clock into our everyday experience, we have to fundamentally redefine mass. Because how does a computational clock translate into the feeling of a heavy object or massive planetary orbits? Well, in a compiler universe, mass is not a physical object at all. It is defined as computational viscosity. When data moves through curved geometric pathways, it forces a processing lag, or latency. The master clock requires more computational cycles to render that specific shift, and that creates topological resistance. So, what you feel as physical weight is literally pure processing lag in the cosmic engine.
To visualize this, picture the Hodge bundle cache. It serves as this massive architectural blueprint, organizing all the physical forces before they're ever rendered. As the data pathways push through this structural grid, the sheer complexity of those blueprints creates resistance. The system physically slows down to process the data, and that precise slowdown, that lag, is exactly what manifests in our reality as mass.
Let's ground this wild idea in some standard physics. Take the mass of an electron, which physicists measure at 0.511 mega electron volts. In the cosmic compiler model, That number isn't a physical weight on some tiny microscopic scale. No, it is an exact, mathematically fixed parameter of topological resistance. Literally 0.511 MeV of pure computational lag. It is absolutely mind-blowing to think about it like that.
And this brilliantly illustrates how gravity fits into this whole computational universe. Through the Langlands reciprocity map, we can see that gravity is not an independent particle at all. You are never going to find a graviton. Instead, gravity is the routing latency of a universal API. It is simply the computational footprint left behind when the cosmic system has to translate complex data packets across vastly different force spaces, like shifting instructions from electromagnetism over into the strong nuclear force.
Section 4. Preventing universal system crashes. So if reality really is this software architecture processing infinite amounts of geometric data, how does it avoid crashing? I mean, processing infinite data would instantly cause any normal computer system to blue screen. The system has to rigorously regulate its bandwidth. Under normal conditions, we experience what's called standard reality, which actively includes a safe, built-in 1% mathematical stutter that flawlessly syncs the rendering frame rate. But if the phase noise scales up too high, you hit a catastrophic hypertorsion event. This extreme bit shear would literally choke the rendering volume of local spacetime down to near zero just to stop the system crash from spreading.
To prevent that, there's essentially a torsion throttle with a strict line drawn at the golden criticality damping value of 0.2361. The mathematical structure of the universe actively dampens its own geometric footprint, utilizing this exact throttle threshold to maintain phase lock. It's doing this constantly, ensuring the continuous, unbroken reality you experience every single day doesn't just suddenly freeze up on you.
So the crucial point is how the system handles this infinity problem. Normally, open algebraic geometry would cause unbounded potential and massive infinite density spikes. To fix this fatal flaw, the system executes a process known as Arakelov compactification. Now, don't worry too much about the heavy terminology there, just think of it as a really cool piece of mathematical trivia. What it actually does is act as the ultimate failsafe. It mathematically seals infinite density leaks by literally appending a continuous boundary right at infinity. It closes the open curve so that the data pathway cannot overload the processor.
Section 5. Fixing bugs in shared networks.
Let's explore how the universe handles physical symmetries. If you know a bit of physics, you have probably heard of charge, parity, and time symmetries. But I want you to look at them here as compiler operations. CP and T symmetries are essentially a low-level file restoration protocol. If a process bifurcates, these protocols step in and force any asymmetrical arithmetic remainders to subtract out to perfect zero. It restores the global data trace instantly. It is quite literally real-time data validation, ensuring the universal code stays clean.
And oh man, look at what this does to quantum entanglement. Standard physics has always struggled to explain how two particles communicate instantly across vast physical spaces. But in this framework, they aren't traversing physical distance at all. Entangled particles are simply anchored to the exact same localized retrieval loop within the unrendered database core. Changing particle A instantly recalculates particle B at the source, right before the frame even renders. There is no spooky action at a distance happening here, it's just a shared coordinate anchor.
Section 6. Rendering the flawless frame.
This right here is the ultimate synthesis. Let's move to and see how this builds together into one cohesive system to generate the reality currently sitting right in front of your eyes. First, you stack the L function packages, which serialize mass and charge data. Then you add the Deligne odometers calculating exact metric shift distances. Pass that whole thing through the Langlands API to translate across physical boundaries. And finally, apply the GRR push-forward brakes to cancel out any infinite anomalies. The whole shebang funnels down into one beautiful, elegant equation, the Adelic product formula.
And look at what that entire stacked formula equals. Exactly 1.0. The universe is an immaculately balanced compiler. Every operation exists simply to ensure the net arithmetic variance of reality perfectly equals 1.0, rendering a solid, continuous spacetime. Just let that sink in for a second. Your entire physical existence, all of space, all of time, every planet, every single star, is just perfectly balanced math, constantly resolving to exactly 1.
Which leaves us with a deeply provocative final question to chew on. If our entire reality is truly just the flawlessly rendered output of a cosmic compiler, what does that make you? Are you the localized readhead, the observer actively driving the rendering process of the universe? Or are you just another pre-written line of code tucked away within the database core? Definitely something to think about next time you look up at the night sky. Thanks for diving into this incredibly fascinating system with me, and I will catch you in the next explainer.